Okay, so we're continuing with the ISIS troubleshooting, and I just want to point out something really subtle here, which is displayed in the diagram we have in the middle of the board. Now, the diagrams that we're sort of used to, and these are really very normal. We see the areas here in the ISIS, um, whatever format you want, and we see the levels here. This is level 2, this is level 1, and that's fine. And we think, okay, happy days. However, we're used to the levels or the areas meeting on the wire, as we know, because of course with OSPF the areas meet on the router. I mean, one area will be on one interface, one area will be on the other. So we're aware with ISIS that the areas meet on the wire, and we're familiar with that. However, there are really two rules that really help us here. The two ISIS rules, easy to forget. So the first rule is, where areas meet, you must have a level 2 relationship. And what that means is that this router must be running level 2 to this router, as we see here. This has to be a level 2 relationship, because if it isn't a level 2 relationship, it doesn't work. Now, the second rule is that the whole of this router must be within an area. You can't have a router in more than one area, but you can have a router in more than one level. So the orange diagram below, which we're much less familiar with, is actually the same diagram as the purple diagram above. The orange diagram is what the purple diagram means with levels. You'll notice here that this particular router is in level 1. It has no level 2, it has no inter-area connections. So it's level 1. Now by default, Juniper will turn on level 1 and level 2 on every connection, and that's fine. So by default, sure, this will be level 1, level 2. But the point is that inter-area, it must be level 2. And that's why we have level 2 only, and why we turn off the level 1s with level 1 disabled. Why does this matter to us? Well, it does. Because if you were to log into this router here, and you were to do show route, and you weren't to have any redistribution between the ISIS levels, you would see a lot more than you expected. Because, of course, if you look at the level 2, you would be in a level 2 router. So you would see all of the level 2 database. And the level 2 database includes this level 1, this remote level 1 here. Okay, so the last part of this is this monitor traffic command, which is a really fantastic command. We're on a Unix based system, or a Linux based system, so that gives us access to some of the stuff that's underneath. The output looks very similar to TCP dump, but with the polish and reliability, because obviously there's risk when you turn on this type of processor intensive service on an interface that's moving vast amounts of traffic. What's nice here is you can specify the traffic count before you begin, so that's a mitigating factor on your risk there. Very, very nice. And with the detail flag, you can even see the authentication type, where working here on an adjacency that won't come up, and it's authentication based, we can see the password in clear text. The other part of this is the point-to-points. We're doing run show ISIS adjacency. We can see the subnetwork attachment point, and that tells us that it's a MAC address clearly. That tells us that we're on a multi-access segment, an Ethernet, or some sort of, it's a MAC address, so Ethernet. That tells me that we've got a DIS elected. That's ISIS's version of a designated router. We've been asked to not have those pseudonodes, so we're going to run the interfaces point to point, and that turns them off, which is fantastic. Obviously, we've got no resolve on our monitor traffic, otherwise we'd be going out doing DNS lookups, which is disturbing. And we've chosen a size large enough to see the entire packet we're processing the header. It is vastly helpful to remove all of the unwanted levels prior to going too far in the troubleshooting. Otherwise, you can end up troubleshooting at levels that aren't meant to come up.